I'm Karen Donoghue. This is Craig Newell.
Hello.
From HumanLogic, and I'm a Tufts computer science alum. And we're going to talk to you today about some work we've been doing on crowdsourcing data for environmental monitoring for consumers. And we're going to let everybody know that we're recording. Thank you to Professor Ming Chow for inviting us to speak. We're really happy to be here. And we're going to talk about interaction design for IoT, or Internet of Things devices at very large scale, focused on air quality monitoring, which is something of interest to us. It was sort of started by, I was given a prescription for an inhaler for some asthma, and then we decided to say, like, hey, can we monitor some of the local air quality that we're experiencing? And that's how it started. And the first thing we want to explain is what particulate matter is, or you sometimes hear it called PM. It's also called particle pollution. And it's important because the small particles, which are can be less than 10 micrometers in diameter, can get into your respiratory system. They can get into your upper respiratory tract if they're less than 10 micrometers, or even smaller, 2.5, PM 2.5 particles, into your lower respiratory tract. And even very fine particles can get into your respiratory system and even your bloodstream. So that's why there's a health impact for particle matter. And what we've seen is a rise in low-cost PM sensors.
So in the last few years, the technology in order to measure air quality has gone from being a huge lab-style environment to something that an individual user can now actually purchase and run themselves. The basic technology behind PM sensors is that you have a small fan that blows air across a laser, and you measure how many times the laser is interrupted as the particles in the air go past the laser. So you end up basically with a counts per volume of air that you're pushing through. You then make an assumption about what the particulate matter is. Is the particulate matter soot from cars, or is it dust from something, or is it fires? And that gives you a density. So you can convert from this counts per cubic meter into a micrograms per cubic meter measurement, which is normally what you hear from particulate matter. Now, obviously, just knowing micrograms per cubic meter, it's an interesting scientific number, but it doesn't really relate to much. So what you then do is you then convert this micrograms per cubic meter into a health impact. And this is very fuzzy because exactly what the particulates are can obviously impact greatly upon what the impact is. But you'll have each government around the world has basically come up with their own formula where they go from this concentration to an air quality index, an AQI value. And that AQI value then maps it as to whether it's healthy, unhealthy, dangerous, hazardous, and so on from that perspective. So now that we have a low-cost measurement way of measuring air quality that everyone can do, we can build a basic IoT system. And so just like any other IoT system, we have a whole pile of sensors. In the case of air quality, there's lots of different groups around the world that are all assembling their different sensors. They communicate over a network back to the internet, and then finally into a cloud source to hold the data. And obviously the devices that are accessing the information are also coming across the internet back into these cloud pieces. The actual sensors themselves are surprisingly simple. You can build them for as little as about 30 euros. So there is a group called Luftdaten in Europe that puts together designs for being able to assemble themselves. So it's really just the laser sensor, which is the most expensive and complicated portion of the system. You connect that to a microcontroller. It can be as simple as an Arduino or as fancy as a Raspberry Pi. And then you have to be able to put this device out into the environment. So you normally need some weatherproofing case to go onto the top of it. There are obviously both commercial and semi-commercial people that are also put these together and package them depending upon how robust a case and how much redundancy, and do you want a battery and all of the other pieces to go into it. The next stage is connectivity, because we have to take this little sensor that we have and we have to transmit the data back to the pieces. Interestingly, although there has been a lot of discussion over many years about all of these fancy IoT communication mechanisms, whether these are things such as just reusing the mobile phone networks or whether these are dedicated IoT networks, pretty much none of this seems to have come to real life in the consumer world. And what's happened is that people just reuse Wi-Fi. Wi-Fi has become ubiquitous, everyone has it, and they can easily get themselves onto it without any extra costs. In the same way that we found that simplicity has taken over is in the protocols that are being used. So since we're just Wi-Fi, we're communicating across the internet, people have given up on all of the fancy IoT protocols, MQTT and other pieces, and just gone for basic HTTP REST calls to transmit the data from the sensors back into the cloud. So it's a strange world where the technology, and lots of people have been discussing all of these really innovative ways of being able to efficiently do IoT, but at the end of the day, it's just the simplest thing just works, and that's the basic story from everywhere. So once we got the data and we're transmitting it across the network, we have some sort of a collection network. And here, obviously, like the internet, there's not one single connection network for anything, but there's a number of different groups on the internet run cloud scale databases to store the actual air quality readings themselves. So we have Luftdaten, which is sponsored by the European community, very much of a community-based system. We have other systems such as Purple Air and URAD Monitor, which are cloud services run by vendors that make air quality meters for consumer and sometimes industrial use. And then we also have governments. In the case of the US EPA, runs a network called AirNow. It's probably one of the oldest networks where it gathers together all the data and makes available both current and historic data. So there's not one place that all of the sensors come to. And obviously, when we want to access this data on a global scale, we have to aggregate between all of these different sources. The actual access to this data, once again, has really come down to keep it simple, stupid. So all of the discussions around pub sub and all of these fancy APIs have really just come down to the fact that it's all being exposed as a REST API. And whether the REST API returns a JSON or returns XML or it returns a CSV or various other different forms, it's just come down to a basic polling mechanism. And any of the fancier streaming things just really don't seem to have taken root in real life. Obviously, this has an efficiency problem because quite often when you are downloading these data, you download the whole data set, including bits of the data sets that you might not be necessarily interested in from a client perspective. So we sort of have to remember to be able to, when designing these APIs, to add some sort of filtering so you can just have certain attributes come back and not everything. As the number of people interested in this data, so the number of consumers of the data becomes larger, ensuring cacheability becomes a real problem. Because if I have one person accessing the data, then that's one thing. But if I have 1,000 people accessing the data, it's easy to create a denial of service attack against the cloud database from that perspective. And then finally is you have validity. Now, as we said, we're not in this model, we haven't seen people actually use push to push the sensors in. So it's all a polling mechanism. And so it's very interesting. You have to remember to say, what's the validity period? Is this data that I've just downloaded good for the next 5 minutes? Is it good for the next 20 minutes? And pieces. And in the same way, you've got to, against each of the bits of data that you're downloading, you have to say, is this a instantaneous? Well, it's never instantaneous, but is this a 1 second average? Or are you doing a 5-minute average or even a 1 hour average? And knowing the validity periods will then obviously allow the clients to poll at the suitable rate and therefore be able to achieve the system via polling without having to go to the complexities of push. So here with the next part we'd like to just discuss is a case study on a client that we have put together over the last few years that accesses this data and displays it to a user on a phone.
The app is called Local Haze. It's free. It's available for iPhone on the App Store. And what it does is it crowdsources air quality sensor readings worldwide, and it rates those sensor readings for accuracy, and it presents it in a really easy to use user experience. You can see that the data sources are coming from all the different kinds of sensors that Craig mentioned. So Purple Air, Luftdaten, Air Now, Department of State, and the URAD monitor. And also, we're seeing the scale start to increase. When we started, we only had a few sensors, and now we're up to about 18, just over 18,000 sensors, and it's growing. Every week, more sensors are added. I'm going to show you a demo here of the app. So this is actually the map views, zooming into London, being able to now see the sensors that are located in London, drill down, or actually scroll through the set of sensors, and then choose a sensor, drill down into the details, and see the sensor data for that location. You can see that you can pan and zoom and be able to look at sensor data in an aggregated view at a very large scale, or be able to drill down. That was a very important part of the user experience when we went to proceed to design this app. We've had some lessons that we've learned in building this system. We really had to figure out what the user experience was for working with lots of things, lots of entities, and we had to really understand what scale means. And anytime you're going to build any of these IoT systems, you really do want to understand what scale you're building at, and what, is it hundreds of devices, or is it thousands, or millions, sometimes tens of millions. In our in our practice, we deal with device management for enterprise clients where we're dealing with hundreds of thousands or millions of devices. And in this case, we said we have to come up with a great user experience where ease of use is a core attribute. And it always remains a core attribute as we go along for every release with all new features. We really wanted a user experience that was clean and simple, and one that allows an air quality enthusiast who is not necessarily a very technical person to be able to understand the and read the sensor data and sort of see it at a glance, and not have to really understand too much technical detail to get some real value out of the experience. We had some problems with managing very, very large scrolling lists. So if you remember from the demo, you could see that there's a lot of scrolling when there are a lot of sensors in a location. So we added filtering into the user experience. Again, we wanted it to be really simple. We wanted the user to be able to say, hey, I'm only looking for air quality sensors in London where I live, and I want to be able to see them quickly and be able to see what is the air quality for this area, and are there particular sensors that I want to pay attention to. In this case, you can see there's a variety of quality of air for this location, and it's being reflected in the color of the face, but also the badge, the confidence rating on the lower right, which is the little hand. Sometimes the hand is yellow and says okay, and in, say in the case of Londonderry, the measurement from the actual sensor is bad, the face is red, but the air quality rating, the confidence rating, is actually good. So we want to have this, we have this sort of two-dimensional rating system that shows the actual data coming in from the sensor, as well as the confidence rating for that sensor reading. After we worked on filtering, we said, oh, users are asking us, they're saying, I have a sensor on my porch. I really want to be able to favorite it so that it's pinned. I don't have to scroll through lots and lots of sensors to see my sensor. So we did that feature. We added this favoriting feature, which just basically pins the sensor to the top of the list. You can see it on the right here. And then we added the map view later on because we wanted to help users really understand, sort of geographically, get like a geospatial view of their air quality as they were looking at these sensor lists. And so we had some problems. When we started, we had a real problem with this too many sensors that were on the map. So on the left, you can see the early design. Too many sensors, it was really hard to read. And so we sort of said, okay, let's take a minute here. Actually, it was a tough change architecturally, but we had to sort of say, okay, what's the right level of abstraction of the air quality data at particular level of scale? So in this case, on the right, we use a clustering approach where we cluster the readings for the sensors in a geographic location. Then when you zoom in and out, you see those clusters sort of change in scale. We felt that a level of abstraction like this was very, very good for users to be able to look at a region and say, oh, I can generally get a sense of the air quality, but now I want to be able to drill down and look at a particular region and look in detail at the sensors in a particular area, and then look at individual sensors. So we think that it's also important to really understand what attributes of the data really impact the end user's perception of what we call trustworthiness. How trustworthy is that data? Do I trust it? And what you can see here is an example of a sensor detail screen, but we're really pushing this notion of confidence in the data. That's really making the user feel like, I'm confident that this reading is actually trustworthy. I can trust it. We also feel that precision, users are asking us for more and more granular data for their air quality sensor readings. And so we want to be very precise. And we feel like precision is another one of these attributes that helps build trust in the data and the experience, and also recency, as Craig was mentioning. Some of these APIs have data that is coming back at different timescales, and so we want to be able to show that the data is actually accurate in terms of its recency. Old data is not necessarily trustworthy, so we want to be very clear, and we also want to be very transparent as to the source of the data. So this where the data is coming from, and then also the location. So all these attributes taken together, we think, contribute to this notion of trustworthiness in the user experience, and that's one of our core beliefs, is creating a really trusted experience. Our advice is that you may want to look at using different interaction models, because users need different kinds of interactions to be able to get the data that they want. So we had to use multiples. On the left, you can see we used a interaction model that involves panning and zooming and pinching and zooming into the map, being able to look at sensors at different levels of scale that way. And in the middle, we used list scrolling, but then we also had to do filtering. So that interaction model included having to filter and be able to cut down list sizes to help the user navigate. And on the right is an example of drill down. So you're actually drilling down into the sensor detail and be able to interact with it that way. And so we really feel that these are all attributes that have helped to build confidence in our user population. They tell us that they really trust and value the experience, and they're constantly giving us feedback on new features that they want. We have quite a backlog of features that we're working through. So with that, we want to say thank you to everybody for listening in. And if you have any particular questions, we'd be happy to answer them via the chat.